Hapa najua toka. That's nice. So, explanation in Kubernetes this guy. Skill technology. Take everyone follow, right? So now, Kubernetes ni an orchestrator ya containers. Ngapi nazo containers? Okay. Sawa. Kanya tuju ka kesho ya. Okay. So, after talking some history of Kubernetes, Kubernetes is an open source tool for automating deployment, scaling, and management of containerized applications, right? So, he started on a Google, he followed from this project. So, see what it means on Google, right? It's a mega corporation with a lot of servers and a lot of compute, right? And basic computers are jobs or applications that you need to run, and most likely they're running them in containers, right? So they built Google Log, but then they started Kubernetes and phased out this pole. Then they gave out Kubernetes to, not give out, donated to the CNCI. How many know this organization? Cloud Native Computing Foundation. Okay, nice. Another one to put on here. That's good, Chad. Okay, just kidding for one. Basically, it's a platform that offers items, like for example, certifications, Kubernetes, actually non-Kubernetes programs. One copy for Mr. Sydney. Oh, for Mr. Sydney. So let me explain. Okay, from my understanding, it's true what you said. But from what I know, Kubernetes, cloud native, they mostly deal with cloud technologies and research on it. They also oversee projects. For each of projects, we can have certain phases like incubation from when they acquire the project. It's an open source project, and in a lot of users, they can, like, we can take you guys and maybe help you guys for your project. So is that going to get that? Okay. So about what is a container? So in the most simplest explanation, what a container is, you can think of it as an environment in which an application can run. You get, like, you can have a container, let's say, that uses a Python container, right? In a Manisha. It's not a whole, wait, natural virtual machine. Virtual machine. Okay, no problem. So, the way you have this traditional computer, right? You can have one OS, and that one OS in control the hardware, everything, right? So a virtual machine is having the same machine inside the machine. You get it? Okay. Let's say I'm running Linux, right? But now I want, let's say, to run Windows, but I don't want to install it in my computer. What I'll do is I'll go to the internet, download something like VirtualBox, and then virtualize the Windows OS. So you run the whole OS as an application in your computer, right? So that's a virtual machine. Let's say when you're running applications, let's say when you deploy it with maybe AWS or your cloud provider, chosen cloud provider, right? You buy a virtual machine, then you run your application there, right? So for that, let's say you need a couple of instances of that application. See, spinning up other virtual machines fast and resource intensive, there is a lot of deals, right? And there's a way you can run that application, like you can fold it like it's in an OS, but it's not an OS. It's not running in an OS. So that's where a container comes in. Instead of doing the whole virtual machine, you can do just container, like it's an environment, right? And then in the environment, you install what the application requires. Let's say you're running a backend, a Laravel backend, right? What you need is a PHP and maybe the composer and all that, right? So you create an environment where this app, when it runs, it gets all that, yeah? But it's lightweight. Like in a virtual machine, you are simulating the whole OS. But now in a container, you don't simulate the whole OS, you just simulate the environment, for lack of a better word, yeah? So, first of all, your container, they are a lightweight process. It's not like an OS. So you can run multiple containers in your machine, yeah? Are you good with containers? Okay. So, how many know Docker? Okay, no Docker. So, Docker, you can use it to build images, run your containers, and you can use the online repository to host your image there or distribute it, right? So, what a container, what is the difference between an image and a container? Who wants to answer that? Oh, nice.
An image is just a container that's online. So, a container is just that image that maybe you posted somewhere and expanded. So the images are just static. So you use the image and you have it on a machine or you have it in a container registry. Then the containers itself is like an image, like a container is a running image. That's it.
Okay. And get from that. Yes.
An image is the blueprint of the container, defines how the container will be built, what it will include, how the container is packaged application.
Nice. So, as the two gentlemen have said, an image is just the blueprint of the application, then the container is the actual running application. So, in a simple way, think about it. You see there's a source code. So now source code. You know what source code is, yeah? So think of an email as the source code, yeah? Then what people are running source code. It's a program, right? Program is instructions that are being executed, right? So now you can think of a program as the actual container. That's okay. Okay, so we've seen that we can use Docker to run our images. You can use Docker to build our images, right? So, fine. You've got a VPS. You're running multiple containers of, let's say, your database, your app, and your front end, right? So now, what if one day your app blows up, right? Blows up in that the number of users increase and the traffic increases, right? Now, you'll be facing a new challenge. You go limited in terms of resources, right? And also, if you spin up a lot of containers, it acquires very close to manage every running container because you have to do it yourself, right? Okay. So, now, that deploying other containers is what you can call scaling, right? Are you guys familiar with the word scaling? Okay, so I'll just explain, just give a brief overview of vertical and horizontal scaling. So vertical scaling, let's say you want to scale this laptop, I want to scale it vertically. What I'll do to this laptop, I'll just add RAM and more computing power on it. Get? That's vertical scaling. But for application, let's say we need to scale it more, and I don't really have that luxury of, let's say, adding more RAM the way RAM is expensive these days. vertically. So we need to scale horizontally. So that's vertical scaling, right? So with horizontal scaling, you see your server, the actual running server, like let's say you are in Next, right? You can replicate it. That's vertical scaling. Horizontal scaling. Vertical scaling, you add more RAM, you add more juice to the machine to make it a beast, right? But horizontal scaling, you just make replicas of the same thing, and then you balance the load between those servers, yeah? So, this is where Kubernetes comes in. From our definition, who can remember the definition of Kubernetes? I'm going to say Kubernetes is.
Container orchestrated, right? Especially that image you share of the conductor in the orchestra. Yeah. That's essentially what you guys do.
Okay. So that's one to try.
Kubernetes is an orchestration tool that is used for automatic CI/CD for code.
Nice. You may notice the word scaling and orchestrating, right? So now you remember from our earlier example, let's say you are running a blog. Remember you said that you needed to run multiple containers, right? And you manage it manually. So now that's where Kubernetes comes in. You can build your images using Docker, and then you can use Kubernetes to deploy those images. Yeah? So what Kubernetes does, the following is automatic scaling horizontal. So it can create multiple servers for you on demand. Yeah? Self-healing in that, let's say one container crashes, let's say it's running your database, right? That's bad. So when it's running and then it crashes, what Kubernetes does, it tries to start that container. If it fails, just creates a new one. Yeah? So you have practically zero downtime. Yeah? So not balance. So you can have, let me say, traffic coming to your application or your cluster. So the way load balancing works, yeah. Let's say you're using something like Ingress, you can use rules to maybe divert traffic to certain services within Kubernetes. Okay, I've gone way ahead, but for now, remember load balancing, simplified deployments, self-healing, and automatic scaling. We'll go deeper as we continue. So, this is the architecture of Kubernetes, yeah? So, you have a control plane. Control plane, you can think of it as the brain of your cluster, right? Then, this UI, this is you interacting with the cluster, but you don't interact with the nodes, you interact with the control plane. So the control plane will handle, let's say, creating boards, release nodes, and everything else, yeah? For instance, your API server is the one that manages the state of your cluster. Let's say you have, okay, these workers, think of them as other servers, right? Their sole purpose is to run workload, nothing else. So you have the scheduler. The scheduler, its work is to schedule where pods will run. Let's say you can even set conditions. Let's say you have, okay, two. Let's say you want certain containers to run on this worker. You can how do I say it? You can tell Kubernetes that you want all your pods to run, on one using something called pod affinities, yeah? As ETCD is the database, it's a distributed database. It's used to hold the state of the cluster, right? Are you together there? They're not lost. Okay. So what you just say? Kubernetes is the control plane. It has two components, the control plane, the worker node. The control plane has the brain, or cannot run applications there. Okay, the control plane component is responsible for managing that node, because if you have many nodes, you need someone to actually execute what you want to be executed, right? By that, what I mean is the control plane, right? You want maybe say to create a new pod in a certain node, right? So the control plane, we use the scheduler, and the scheduler will communicate to the toollet to actually create this pod in a certain node or anything, yeah? Are you together till that? Yeah. So the container runtime is used to run this container. So different container runtime. You can use something like Docker or container with a D. So the pods are the actual things that have the containers running inside them. Yeah? So in every pod, you have either one or two containers, but Kubernetes suggests that you just run one container in a pod. But for instances where you need to log your activity or you need to run certain things, you can have another container known as a sidecar container. Yeah? This container you can use something like, is it Grafana? How many know what Grafana is? Grafana and Prometheus. Okay, would you like to tell us?
Yes,
Okay.
you guys can just
platforms or visualizing metrics. Prometheus helps with those data collection, Grafana focuses on visualization.
Okay, so for you to collect that data, you need to be there to actually collect the application, right? So that's why you have maybe two containers running in a single pod. That's okay. So Kubernetes has objects. The class itself has the pods, the one that runs your container, deployments. Okay. So for the deployments, you see you can run one pod, two pods, three pods, four pods, right? So you running that one pod and managing it yourself is kind of hard. So that's where deployments come in. So deployments in Kubernetes, you just tell Kubernetes, when you write the file for deployments, you just tell it, let's say you need to run like your internet, you want like 4 replicas, yeah? Just tell it, hey, I want 4 replicas, and deploy them in this certain node, right? So what deployments do? It will create 4 replicas and always make sure that there are 4 replicas. If one goes down, that deployment will create a new one, yeah? Without you like doing the manual work yourself. You just declare what you want, and then Kubernetes will handle that. Or the deployments will handle that, yeah? And also you can have different deployments. Let's say you can have your backend in a, let's say, backend deployment 1. You can have your database in a different deployment, let's say database deployment, and you have your front end in another deployment. You get this? Yeah. So, services. So for the services, you see, when you created these deployments, you have, let's say, each deployment had 4 pods, right? So you have 12 pods in total, right? You have 3 deployments, each deployment having 4 pods, so you have 12 pods. So for you to manage, for the services, you have 12 pods. Okay, now I'm entering the class. Let's say I need to access your database, right? Okay, fine, I'm in the cluster now. I need to access the data. It doesn't know where to request. Okay, I've missed a lot, but can I just mention some things on Kubernetes network? So every pod in Kubernetes has its own IP address. And remember, these pods are ephemeral. That meaning it can be destroyed and recreated. Each time it's recreated, it comes with a different IP address, right? And surely, you can't keep track of all those IP addresses, right? So, deployments also solve that problem, yeah? And services, you see the purpose that we are saying, let's say in your backend database, yeah? What a service does, it creates a layer, like it gives you one IP address for this IP address below, right? Such that when you hit this service, you can hit any of the ports. You get it? Okay. Are you guys getting it? Okay, fine. So the service allows you to do that. So ingress works with the service. So let's say when someone wants to visit your site that you hosted on Kubernetes, remember we said that Kubernetes has its own internal network, right? So for you to allow people to visit your cluster, you need to create like a hole, like a port. That's the guy was saying, right? To connect to your cluster. So traffic lands on your ingress controller, right? Then your ingress controller, using rules, forwards traffic to the required service. Like let's say your backend service, right? So ingress forwards traffic to the backend service. Now your backend service forwards traffic to deployments to support. I've gotten that flow. Sure. Yeah. Are you good at Kubernetes objects? What example? Okay, I'll explain it again. So, as we say, Kubernetes gives you, let's say, high availability, right? It allows you to run multiple containers. So, these containers run in pods, right? You can have like 10 pods, right? And managing those pods yourself is kind of hard because first, these pods are ephemeral. They can be destroyed at any time, yeah? When a pod crashes, it can be deleted and then created, right? So, how on a challenge, you need to keep track of these IP addresses. Let's say you want to communicate with a certain pod, you get that's a problem, right? Okay. So the way Kubernetes helps you solve this, because you are handling many objects, it gives you pods and deployments. Pods, as I've told you, they run containers, right? Deployments run